Alright, so we are on to the next topic, and this time we will be discussing about the origin of the solar system. Alright, so again, big idea, the origins of the universe and the solar system can be explained by scientific theories. And this time, we'll try to answer the question, how did the universe and the solar system come to be? So, in the origin of the universe, there is an era referred to as stars and galaxies formation. So take note, a galaxy is defined as a gravitationally bound system of stars, stellar remnants, interstellar gas and dust, and dark matter. And the Milky Way is one of the many galaxies found in the universe. Do you know that there are around 170 billion galaxies in the observable universe? So the observable universe depends upon the location of the observer. And from the Earth's vantage point, it is the part of the universe that is observable from our place in the Milky Way. First of all, each part of the solar system, or Earth is a part of the solar system, and it is found in the Milky Way galaxy. So question is, when and how did the solar system start? Now, for a model or theory of the formation of the solar system to be acceptable, it must offer explanations of the solar system's observed characteristic features or regularities. And these regularities are observed in the motion and location of the planets and how they compare to one another. Following here are the characteristic features of the solar system. First, the planetary orbits are nearly circular. The elliptical orbits depart only slightly from being a perfect circle. Second, the orbits of a planet are almost in the same plane. This means that the solar system is almost flat. Third, all planets revolve around the sun in counterclockwise direction. Fourth, all planets except Venus and Uranus rotate on their own axis in counterclockwise manner. And finally, the distances of the planets from the sun can be expressed in simple relationship called Bode's law, named after German astronomer Johann Bode. So the calculated distances and the observed distances of the planets from the sun are almost the same, with the exception of Neptune. Alright, so now that we know the features of the solar system, we can now discuss the early theories on the origin of the solar system. So in the same way that scientists explained the origin of the universe using theories, there were theories that were created to explain the origin of the solar system. And some of these theories work around the mechanisms involved in the formation of the universe, while others use the aid of other celestial objects to fit an existing theory. So the first one, we have the vortex theory, made or proposed by René Descartes, a French mathematician and physicist. So he was one of the first proponents of a model of the origin of the solar system. In 1644, he proposed that the solar system formed into bodies with nearly circular orbits because of a whirlpool-like motion of the pre-solar materials. So he explained how the orbits of the planets are the primary vortices and the satellites around the planets are the secondary vortices. Thus, the name vortex theory. So, in Descartes' vortex cosmology, the mechanism involves the collapse or dissolution of a vortex in which a stellar body is embedded in its migration to another vortex as a transformed planet. So the transformation hypothesis was abandoned with the rising influence of Newton's law of gravitation, explaining that the origin of the solar system is based on gravitational attraction. So Descartes' theory represented the first evolution-based theory of planet formation. So next we have the collision theory. So George Louis Leclerc Buffon, a French naturalist in the 18th century, proposed that the planets were formed by the collision of the sun with a giant comet. So the resulting debris formed into planets that rotate in the same direction as they revolve around the sun. Next, we have the tidal hypothesis. So British astrophysicist James Hapgood Jeans and English astronomer Harold Jeffreys proposed another theory explaining how the planets were formed from the substance that was torn out of the sun. So as a speeding massive star passed near the sun, it pulled off material due to gravitational attraction, and the torn off material subsequently condensed to form the planets. So that's the tidal hypothesis. The next we have the encounter hypothesis. So Buffon's collision theory and John Jeffreys' tidal theory are often referred to as the encounter hypothesis. So in these models, a star or comet passed by the sun to draw out a stream of solar gas that condensed to form the planets. One common flaw of these theories is that it assumes that a star would just, come close enough to the sun, which is an event that would be highly unlikely to happen. Moreover, genes even acknowledged close encounters with another star to be very rare. Another flaw is that the solar system or the solar matter that were either pulled or ejected could not have acquired sufficient angular momentum to condense into planets. So next we have the nebular hypothesis, which is proposed by Immanuel Kant and Pierre-Simon Laplace. So they proposed that a great cloud of gas and dust called the nebula collapsed because of gravitational pull. So as the cloud contracts, its rotational motion increases. Right, so as the nebula collapses further, local regions contract on their own due to gravity, and these local regions became the sun and the planets. So the nebular theory proposed a single-step process, and it suggests that most of the angular momentum of the system is in the sun. So if the nebular hypothesis was accurate, the sun would be spinning much faster than it does according to the law of conservation of angular momentum. However, the sun has only 2% of the angular momentum, and the remaining percentage is in the planetary orbits.